Hi, so we're going to look at similar figures today. Similar figures goes right along with proportions and ratios, and here's why. Two figures are going to be similar when the corresponding sides are proportional and the corresponding angles are congruent. So let's talk about what that means. Let's actually start with the second one when it talks about the angles being congruent. Remember that congruent actually means equal. So the first thing you're going to look for is, are all the angles equal to its corresponding angle? So if you take a look at the picture, looking at the angles, angle A and angle D are corresponding angles with each other. That means that angle A is going to equal angle D. Angle B and angle E are corresponding, so they're also going to be the same numbers. And angle C and angle F are corresponding, and so they are also going to be the same. So one of the first things is, if you're looking to see if two shapes are similar, you need to make sure that the corresponding angles are congruent. If they're not, you can actually stop right there because the shapes would not be considered similar. The other is proportional. The sides are going to be proportional, meaning that they're going to be changing at a same rate with each other. Meaning one side cannot grow 3 feet and the other side do 5 feet unless that's proportional with the size that we've got. So keep that in mind. We're not going to be just adding on or subtracting from it. These shapes are going to be changing proportionally, meaning they're going to be changing at the same rate. So let's do examples. The first one here, we want to find which rectangle below is similar to rectangle ABC. So angle ABCD, which is up at the right-hand corner, has the corresponding sides of 4 to 6. So that's what I'm going to put here. My first one is 4 over 6. What I want to know is, does that equal one of the others? So I'm going to look here at this first angle, angle EFGH. And here you do have to make sure you set this up in the correct order. So since I wrote the 4 first, I'm going to do the corresponding side, which would be the 2. And then here we've got the 6, so I'm going to do this corresponding side, which would be 4. So my question is, now that you've got it written out, is does 4/6 equal 2/4? Well, if we simplify each of these, and here I would simplify 4/6 to be 2/3, and then I would simplify 2/4 to be 1/2. Obviously, those do not equal each other, so no, this first shape is not proportional. It is not similar. So let's try this next one. So again, I'm starting with 4 to 6. We do have to write these right. So then I've got 6 to 9. So now let's simplify again. Here I've got 2/3. Here I've got 2/3. Yes, this one is proportional. And let's just check on this last one. I've got 4/6. And here I've got 2/8. So does this equal? So again, let's simplify. I've got 2/3 and I've got 1/4. No, this does not. So that's just a very easy way to tell if shapes are proportional or not, if they're similar. Now let's look to see what we would do if we are missing a side, which tends to be the more questions that you're going to see. All right, so if you can tell here, we are trying to find angle X, the measure of a side X. That's going to be side UV. And I'm going to set this up just like I did before. Here in this first triangle, I've got 20 as one side, and I've got X with my other missing side. Make sure you write this in the right order. So since I did the 20, I'm going to look for the corresponding side, which would be this side. So then I've got 4. And then I wrote my X, and the corresponding to that would be 7. Well, guys, once you have it set up like this, it's turned into just a straightforward proportion. And we would solve it just like we did by solving proportions. So we would do 4 times X equals 20 times 7. Let's go ahead and do 20 times 7, which would be 140. And then we would divide by 4 on each side. So X is going to equal, let's see, 35. And it does have meters, so make sure we put our label with it. Perfect. Let's try another one. So here I've got 15 and 13 and X and 39, and I'm going to write it just like that. I've got 15 to 13, and the corresponding sides here would be X to 39. And again, I'm going to solve this just like I would in the other proportion here. So I'm going to do 13 times x equals 15 times 39. So let's go ahead and clean that up. So I've got 13 times x equals 585, and you can just go over to the side to actually work that out. And then we need to divide by 13 in order to get x alone. And when we divide that by 13, we end up with 45 millimeters. And any of that computation that you needed to, you could just go over to the side and work that out. Great, let's try a word. So it says that a shadow of a full, it's called shadows. A flagpole casts a 20-foot shadow. So look at your picture. There's your flagpole. There's your 20. At the same time that Humberto, who is 6 feet tall, casts a shadow of 5 feet. So he is 6 feet tall and his shadow is 5 feet. What is the height of the flagpole? Assume that the triangles are similar. So here we're going to set up our proportion. So we've got 20, or x over 20 equals 6 over 5. Do our proportion. So we've got 5 times x equals 20 times 6. So let's just clean that up, and 20 times 6 is 120. Divide by 5 on each side. So x is going to equal, let's see, that goes in there 2 times 24 feet. And so that's what it deals with similar figures. What I think of similar figures is it's not too hard or difficult, especially after you feel really comfortable with solving proportions. You just want to make sure that you have your numbers written on the right way, and hopefully y'all took really good notes while we were talking about where the numbers go. Your corresponding sides need to be across from each other. And other than that, it's just solving your normal proportions, and make sure you label at the end. Good luck.